Hi, welcome. In this video, we will solve problem top k frequent elements asked by companies like Amazon, Microsoft, Facebook, Apple, and Google.
Now let's check out this problem, top k frequent elements. Okay. Again, one very good question on sorting. So let's quickly see. So given an integer array, so this is my integer array of nums and an integer k is given. Okay. And return the most frequent element, right? So I need to return the top k most frequent elements. You may return the answer in any order. So let's see. So let's understand the sample input and output. So here in the nums, I have how many ones? So I have three ones. Okay. How many twos are there? There are two twos. And how many ones are there? There is three one. Right. Like ones. There is only single thing. Now I need to find top two most frequent element. Right. This is k most frequent. Top two k most frequent element. So what is the highest frequency? This is already arranged in the highest frequency. Right. So if I say this is already arranged in the highest frequency. So this is the most frequent element. This is the most frequent element. Then this is the most frequent element. And then this is the frequent element. So can I say my top two most frequent element are these two? Right? These are the top two frequent elements. Okay. So one and two are the top two frequent elements. And that's why this is the answer. And here in example 2, okay, there is one single element in the array. And if I say when there is a single element in the array, which is the most frequent element, that itself is the same element with most frequency. Okay. So now let's see how we can solve this problem. Okay. So what I will do, I will create one nums array. So suppose this is my nums array, or let me define it as simple array. Okay. And what are the elements? So let's suppose I have one, one. Or let me arrange in a different manners. This is the 1, 2, 2, and 3. Okay. And I need to find the top most frequent element. Let me put the indexes here and then top k frequent element. So now let's see. If there is something that I need to find here, that is the top k frequent. That means I want data. I want data that should be sorted. Okay. In with respect to frequency, can I say with respect to frequency, right? Because I am judging here frequency, which is the most frequent element, right? What are the two most frequent element? What are the three most frequent element? So I am judging on the basis of frequency. So I want a data first, okay, in with respect to their frequency, okay, with respect to their frequency, and I will then sort the data as per the frequency. Okay, as per the, I will say, high frequency. This is our goal, right? I will say this is our goal. Okay, so what we can do here, okay, what will be one of the approach that if I take it here, that is the first approach that comes to my mind. That is, I will take one element, okay, one element, okay, and then I will find the count of the element in the array, right? So I will find the count of the array, like count of the element in the array, right? So for one, okay, so let's see for one, what will be the count? So here I am maintaining the count. The count is 3. For 2, what will be the count? Count will be 2. For 3, what will be the count? The count will be 1, right? So these were my all elements, right? So what I can do, I can here add one element in my array, right? With the element and the frequency. Okay. So I will add the frequency of 3, okay, like this. Then the second element 2 with their frequency 2. Then the third element 3 with its frequency 1. So this will form something like 2D array, right? Or I will say simply array of arrays, that is a 2D array. Okay. So here you can see, here I have the element, here is the frequency. And once I get it, what I will do, I will sort the data. I will sort the data. I will sort this data with respect to frequency. Okay. So here this data is already sorted. If I sort this data is already sorted with 1 with 3, 2 with 2 and 3 is 1. So this is already sorted. Okay. So the data, there will be no change. And what I will do, then I will, once it is sorted, then I will create one array. Okay. And then again one additional space. Okay. And I will put the top k elements there. Right. So what is the k? Okay. Just give me a second. So what are the top k elements here? So here we have 1 and 2. These are the top two with frequency. Okay. So I will put in an array. That will be my answer. That will be my answer. Clear? Clear? So now the only thing is, suppose you are optimizing sorting, right? We need to sort the data, right? Once we found the count, right? We need to sort the data. So here the time complexity, if I take the most efficient time, here will be n log n. Okay. And here what we are doing, we are taking one element and then finding the count in the elements of in the array. Okay. Then I'm taking a second element, finding the count. So this will take around big O of n square. Okay. So this approach will give me the time complexity of big O of n square. Right. Big O of n square. Here we are taking an additional space here. So you can see we are creating a 2D array. So that will be of n elements. Okay. And the size will always be 2, right? One for the element, one for the frequency, right? So if I say my size of the 2D array will be n into 2 always. So that will be 2n. Okay. 2n. And here this is one resultant array. So you can consider that this will be our result, right? This is I need to show as the result. So we won't consider it and we are getting 2n. So the space complexity here will be big O of n. So this will be the space complexity and this will be the time complexity of this approach. And here the basic approach is, right, we are checking by count, right? That's why it is getting big O of n square. Now let's see how we can optimize this code. Okay. So again, I have one array. Let me take with some different elements. Okay. So I will take 3 with 2 count. Then I will take 1 with 3 count. And then I will take 2 with single count. Okay. So here this will be the order. Okay. Now let's see what are our steps. What are the basic steps what we are doing here. Okay. So first what we need to find the frequency. Okay. I will say I want to find an element and frequency relation. Element and frequency relation. Then what I need to do? I need to sort the data. Sort the data according to frequency. Okay. According to the frequency. And then I need to choose the key elements. Okay. Or I will pick the top key elements. Pick the top key elements. These will be my approach. Right. So here in the our approach one, okay, approach one, in the first step, right, in the step one, okay, we were counting, right? So when we were counting, so that's why the time complexity was coming big of n square. Okay. Sorting was taking big of n log n, right? N log n, but element and frequency relation, we are getting big of n square. So what we will do in this approach, what we will do is this approach. So because this is an element and frequency game, we should always think whenever there is a frequency word, we should always think for maps, right? Objects. You should always think for maps, object, hash maps, dictionary, right? all these are same. So let's quickly check. So I will create one object here. This will be my object. Okay. Here in this object, I will upload the frequency. I will add the frequency, right? I will check is 3 is defined. Okay, let me put key and value here. I will check is 3 is defined in my object. No, it is not. So I will define 3 with one frequency. Then I will check is 3 is defined. No, it is, yes, it is defined. So I will update the frequency to 2. I will check 1 is defined. No, it is not defined. I will update 1 with one frequency. Is 1 is defined? Yes. So I will update the frequency. Is 1 is defined? Yes. So I will update the frequency. Is 2 is defined? No, it is not. So I will add 2 with one frequency. So in the last, we will get the data something like this. 3 with 2 frequency, 1 with 3 frequency, and 2 with 1 frequency. Okay, key value pair relationship. Now what we will do, we will put all this data into an array, right? Into an array and form a 2D array. So basically, I will add 3 with the value of 2, and I will add 1 with the value of 3, okay? And I will add 2 with the value of 1, right? So we will form this array of array, okay? We'll say a 2D array of our data. Okay. Here, this is my 0th index element. This is my first index element. This is my second index element. Right. Now what we will do? Now we will sort the data, right? So first step is done, right? And now we are ready to do the second step, that is sort the data. So let's sort the data, right? And if I sort the data will be like, sort the data as per the frequency, right? Remember, so which is the highest frequency? 3, right? So 1 will come here with highest frequency 3. Then 3 will come with 2, and then 2 will come with 1, like least frequency. So this is my sorted data. Can I say this is my sorted data? Now from this sorted data, what I need to do, I need to pick the only 0th index element, right? Here you can see this is 0 and 1. This is complete 0 index, but here this is 0 element, 0th element. Again here, this is 1, this is 2, and here this is 0, this is 1. This is 0, this is. If I create a 2D array of it, so how it will be? So it will be like this. So this is my 3 cross 2. Okay. 2D array with 0th index, 1 index, and 2 index. And I have what? 1 with 3 frequency, sorted data. 3 with 2 frequency, 2 with 1 frequency. Now what I will do? Now I will iterate a loop, right? I will iterate a loop till k time, right? Till k, or even say k times, or till k, right? It will start from 0 and it will go till k, and I will pick the k most frequent element. So suppose here k is 2, so I will pick 1 and I will pick 3, right? And here this will be my top k frequent elements. Top k frequent elements. Okay. So again, you can check what we have done. Basically, we have find the element frequency relationship, and we sort the data, and then we pick the top k frequent elements. Now let's quickly check out what will be the time complexity here. So element frequency relationship will take big O of n. Element frequency relationship will take big O of n only, right? Sorting the data will take big O of n log n. Okay. And pick the top k frequency again will take big O of k, right? So I have big O of n, okay, and big O of n log n. Then I have big O of k, and from here these three, right? I will take the maximum one, okay, because that will take the maximum amount of time. So big O of n log n, and that's why the time complexity here is big O of n log n, right? This will be the time complexity here. And now let's check what will be the space complexity here. So here I am taking in a space, right? So what will be the space of the object? It will be big O of n, okay? Here also I am taking one space 2D array, that is also n, right? So even space complexity will also be here big O of n, right? So we have reduced the time complexity and keeping the space complexity same, right? We just need a good data structure, that is objects. Okay. So yeah, this was the whole code. This was the whole approach of this problem. Okay. In the next video, we will see how we can implement the code of this problem.